Hi, my name is Aneta and this is Chemistry at Glance. And today's topic is the wider impact of chemistry. This is quite a short topic, but they can incorporate some math calculations in it as well. So we're just going to practice some questions. If you're not familiar with the topic, visit my blog. I leave all the links in the description box below. And let's start the video. Okay, so this is the first question. Motor vehicle environmental effects are judged on the grams of carbon dioxide emitted per kilometer of travel. The combustion equations for bioethanol and ethane and the energy liberated are as follows. Bearing in mind that the car is driven by the energy liberated, state which fuel would be more friendly per mole on the basis of these results, given your reason. So first of all, you probably look at the energy they liberate because this is the energy they use to drive the car. So obviously, ethane releases it's not much more, but it's definitely more energy than bioethanol. However, you also have to look at the fact that bioethanol, as the name suggests, it can be renewed. However, ethane is not renewable. So on a longer scale, although the energy of ethane is bigger than bioethanol will be more friendly. Because of the link to global warming, much effort is being devoted to investigating how emissions of carbon dioxide into the atmosphere by power stations burning fossil fuels can be reduced or eliminated. One area of investigation is the removal of carbon dioxide by sodium carbonate, and three possible reactions are as follows. Our first part says, given a reason, determine from the equations which of three reactions uses sodium carbonate most efficiently to absorb carbon dioxide. So what you want to do is look at the equations and see the mole ratios. So in the first equation, 1 mole of sodium carbonate absorbs 1 mole of carbon dioxide. However, in the next equation, 3 moles of sodium carbonate are needed to absorb the same amount of carbon dioxide. So we straight away can see that this equation is more effective than this one because it uses much less sodium carbonate to absorb exactly the same amount of carbon dioxide. And exactly in the last equation, we still have 5 moles of sodium carbonate and 3 moles of carbon dioxide are absorbed. Although we have 3 moles of carbon dioxide absorbed, we will need 5 moles of sodium carbonate, so it's still less effective than the first one. Therefore, we can say it absorbs most carbon dioxide. So the reaction number 1 is the most effective because it absorbs the most carbon dioxide per moles of sodium carbonate. Okay, so the next part says, state Le Chatelier's principle. Although this principle doesn't come up in this topic, you might still be asked like things from different topics in different questions. So if you don't remember this principle, go and have a look on my blog, go back to that post and read it out, and then come back. If you already know the principle, you can just write that Le Chatelier's principle states that if an equilibrium is subjected to change, it will move so that to minimize this change. And this basically means that if we increase the temperature of a reaction, the equilibrium will shift so that this change is minimized. So, for example, in this question, the next part of this question says, given your reasons, use Le Chatelier's principle to determine whether carbon dioxide removal will be more efficient at high gas pressure or low gas pressure. So this is an example of minimizing the change. So when we're looking at pressure, it's all about the number of moles. So you can see that on this side, on the reactants, have always bigger amount of moles than the products. This is because, I'll show you how it works. So 1 mole of this, 1 mole of these, 1 mole of these. This is 3 moles. and 2 moles are produced. We have 3, 4, 9 moles of the reactants and 2 moles of products are produced. So still reactants bigger than products. Now we got 5, 8, 11 and 2 on this side. So still all the time reactants have bigger amount of moles than the products. This means that if we increase the pressure, the equilibrium will shift to the side where there is less amount of moles. So in these examples, it will shift to the right. This actually tells us that it's more efficient because if you have more products, that means more carbon dioxide must have been absorbed. However, if we were to lower the gas pressure, the equilibrium will move to the left. So that's not working for us. We want it to be more efficient, so more products form. That means more carbon dioxide has been absorbed. So we have to increase the pressure. And this is part B of this question. Another area of investigation is the use of a new type of plastic membrane structured by means of nanotechnology to catch carbon dioxide whilst allowing waste gases to pass freely through. So this is what I told you before. This unit is not all about weights. It's mostly about carbon dioxide being dangerous, being a pollutant. Being dangerous to human, to the earth, to animals, everything. However, they can also introduce some math calculations using the calculations we learned about in the topic 1.3 chemical calculations. If you're not familiar with this, visit my blog and go to Unit 1 and then find this topic. I hope this will help you to understand these questions now. So the first part says, if 100 decimeters of waste cubed of waste gas at 25 degrees Celsius yielded 275 grams of carbon dioxide separated by a plastic membrane, calculate the number of moles of carbon dioxide in 275 grams separated by the membrane. So, as you know, you can calculate the number of moles by doing mass over mR. This is one of the calculations you have to remember from Unit 1.3, which is chemical calculations. So, of course, you can see we've got the mass, we've got carbon dioxide, so we can find the mR, which is what we're going to do first. So, the relative atomic number of carbon is 12, and oxygen is 16, but we've got 2 of them. So, we basically add this together, and this gives us 44. Now we just want to use the equation to find the number of moles. We've got the mass in grams over the mR. So the number of moles that we have is 6.25 mole. Okay, so the next part says the volume of carbon dioxide separated at 25 degrees Celsius. You have to calculate the volume of carbon dioxide separated at 25 degrees Celsius. And then it says 1 mole of gas has a volume of 24 decimeters cubed at 25 degrees Celsius and 1 atomic pressure. If you visited my post on chemical calculations, you would know that our another equation is N equals V over Vm. And Vm is that 24 at 25 degrees Celsius and 1 atomic pressure. So, of course, we got the number of moles of carbon dioxide now from the previous question. And we know that the Vm is this, because Vm is always given in the question or at the front of the data booklet. So we can just rearrange the equation in order to find volume. 6.25 from the previous question times by 24 in decimeters cubed, so we don't have to change the units. And this gives you 150 decimeters cubed. And the last part of this question says, calculate the percentage by volume of carbon dioxide in the waste gas. So it tells us to find a percentage by volume. And we've got the volume of carbon dioxide formed. And we knew that there was 100,000 decimeters cubed of waste at the beginning. So if 150 decimeters cubed of these 1,000 was formed, we just times it by 100 to find the percentage. And this gives you 15%. So 15% of the waste gases is the carbon dioxide. And the next question, a leading car manufacturer said cars powered by hydrogen will be pollution-free. Give 2 reasons which suggest this is not necessarily true. So, although hydrogen will not give any pollution, combustion of hydrogen will only give out water. However, for this combustion, we'll need electricity. For us to be able to provide electricity for the hydrogen to combust, we'll have to use fossil fuels which will create this electricity. So this is one of the reasons why it's not necessarily true that hydrogen cars will be pollution-free, because we have to use fossil fuels to create the electricity so that we can then use hydrogen as fuel. The other reason is that the hydrogen will have to be transported to be ready for combustion. During transportation, carbon dioxide will be emitted due to the car engine. So this is another reason why this is not necessarily true. I'm sure you can find other reasons, but they are just the 2 I found. And the next question, a spokesperson for safety group said, hydrogen can burn explosively. It must not be used in cars unless it is 100% safe. Comment on this. So what we can comment about this is that yes, here is true. Hydrogen can be explosive with air. And when it's used in cars, it can be spilled from the engine on the road, which can be dangerous to people around, because if it's spilled from the car on the road and it explodes with air, it will explode. And this could cause danger for the human. So in this question, we basically agree with what the spokesperson for safety group said. So this topic is mostly just like showing our knowledge that we know something is wrong, or we know how it can be improved. It's a lot of common sense as well. So there's not much that you have to learn. It's mostly thinking through it. It's as I said, it's basically a lot of common sense. And this is our last question. It's a big question. It will probably be a 6 mark or something. Describe how industry is adapting to the challenge of green chemistry. You should include a reference to aims of green chemistry, materials used or produced, and the energy used. So first of all, what green chemistry is. So green chemistry is doing everything we can so that even though we have pollutants, we do everything so that minimize the amount of pollutants, basically. So the minimize the amount of fossil fuels, minimize the amount of carbon dioxide in the air. So we have to describe how industry is adapting to that green chemistry. So first of all, industries and factories are trying to prevent wastes, not only gases, but wastes. So if they doing reactions, they trying to have the smallest amount of waste as possible. And if you can't stop having waste, they're trying to use these wastes for something else. So although wastes are produced, they are then used for something else, so they basically reuse. This means that they not stay in and are put to bin, they are still used for something else. The other thing that they're trying to do is to increase the atom economy of the reactions. What this basically means, they're trying to produce just what it's needed. So they're not doing more than there is to do. They're just doing the least there is. So if they have to produce something, they will try to do it as fast as you can and with the least amount of other products that are not needed. So that what basically means increases atom economy. As you know from previous topics, atom economy is how effective that product is. So the atom economy increases if you have more of that product that is needed. I hope this makes sense because it's really hard to explain. So only produce what is needed and not produce too much. So another thing that a lot of industries and factories and scientists are trying to come up with is new catalysts. As you know, catalysts make the reaction go faster and are not used up in the reaction. So what scientists are trying to find is new catalysts that will increase the rate of reaction so that less carbon dioxide or less fossil fuels are burned. The next thing we are all trying to do is use renewable energy. As you know, renewable energy like sun or wind or waves, it's never going to be used up. We're always going to have sun, we're always going to have wind, and so forth. So they're trying to use that renewable energy instead of creating instead of using fossil fuels and creating more and more carbon dioxide. And the next thing I come up with was the energy efficiency. Which means basically using the less amount of energy that can be used basically. So not using more energy than we actually need. So this is as well, like we can compare it to us using water. We can save water if we use just the amount of water we need. So when we brush our teeth, we turn off the tap so that water is not wasting, or use less water in our baths. This is exactly the same with energy, or when I said about atom economy and producing waste. We're trying to create as less waste as possible. We're trying to use as less energy as possible because for the energy to be created, we have to burn fossil fuels, which again releases carbon dioxide. So green chemistry is all about minimizing the waste, minimizing the carbon dioxide, which is pollutant, and maximizing what is good for us. So maximize the use of renewable energy because it's going to be renewed, so nothing's going to be a waste. This was everything I had for this topic, so remember everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. I leave all the links in the description box below as always. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. Thank you. Like, subscribe, and see you soon. Bye.